So sum and differences of functions, but this time specifically business functions. So they've given us two key pieces of information. There's a student council and they're looking to sell t-shirts. And it turns out there's a fixed cost of $200 to produce the t-shirts plus a variable cost of $5 per shirt. So it's probably like you got to put a deposit of $200 to get the machines up and running, and then for every shirt you make, it's another $5 it's going to cost you. They've decided arbitrarily that they're going to sell the shirts for $8 each. Okay, so essentially what this is, we have to create the two functions. This here, the first one is our cost function, and the second one is our revenue. Okay, E-N-U-E, there you go, our revenue. So we're going to build the two functions. The first one is, I'm going to say the cost at X, and X is the number of t-shirts we sell. So C at X is equal to, it's $5 per shirt, right? Plus another $200. That's the cost of creating these shirts. The revenue we take in, so R at X, is equal to just strictly $8 per shirt. We don't get any value unless we sell something. And the way profit works is profit is equal to your revenue. So I'm going to say, I'll spell it out and then we'll put the functions in. Revenue subtracted by cost. So in other words, if your cost is too high, then you'll have a negative profit. So for us, we'll call our profit function P at X is equal to, we know our revenue function is R at X, subtracted by our cost function, which is our C at X in this case. Okay. So the first thing we can do is we can actually build a profit function here. Our profit function will replace our R at X with our value. Is equal to 8x, so that was our revenue function, right? We replaced it with our 8x. Subtract, and then technically, we should have them both in brackets because they're technically entire equations here. 5x plus 200. And the reason I want to put in brackets is so this next step makes a little more sense when subtracting. So we subtracted two functions. And because this is a negative, this negative needs to be distributed to both. So it wouldn't just be negative 5x plus 200. It's actually going to be negative 5x minus 200. So our profit function will now read 8x minus 5x minus 200. We combined our like terms and we get 3x minus 200 as a profit function. Okay, so our P at X, our new profit function, is equal to 3x minus the $200. And that makes sense because if every shirt costs us $5 to make, that means we make a profit of $3 on every single one. And we have an initial value of we're in the whole $200. So in order to equate to zero, in order to solve this, we can set our profit equal to zero, find out a break-even point. Another way we can find out a break-even point is actually working with the actual cost and revenue. Okay, and what I mean by that is we know a break-even point is when profit is zero, when the company's made no money, right? That's also when the revenue will be equal to the cost. So we could actually set these two equal to each other to find out what the X value is, so how many shirts we have to sell in order to make it even, or we could set profit equal to zero in this function and kind of work that out. And we'll do both, essentially solve it. The one thing I do want to show, though, is let's go over again to our other page and put our functions in it. The functions we had where one of them said 5x plus 200. I guess we'll have to zoom out quite a bit for that. There we go. There's our function. And our other function was 8x, okay, which is the one we've done in black here. Zoom out a bit. That's maybe a little too much. There we go. And our new function we found was 3x minus 200. So essentially we subtracted the black, the orange from the black. Okay, we subtracted these two functions to find our new. So looking at this, we can probably figure out that this ends up being our break-even point. That's our new point, when x is 0. So if they sell 66.7 shirts, which really doesn't make sense, because you either sell 66 shirts, which would be a profit of, I can't quite get to it, I'm too far out, probably a little bit negative, or you sell 67, we're a little in the positive, right? So let's actually go about solving these two values here. So the two different ways we want to solve this. One of them is we're going to set revenue equal to cost. The other one, we're just going to set the profit function equal to 0. So if you recall our cost function was 5x plus 200. And we're going to set it equal to our revenue function with 8x. So when these two are equal, this is technically break even. Our other option is our profit function will set equal to 0 is equal to 3x minus 200. And you notice these will end up essentially being the same function. Because in order to do this, I'm going to bring my x over to this side, so I get 200 is equal to 8x minus 5 becomes 200 is equal to negative 3x. And I'm just going to stop there before I go, because if we notice, if I bring 200 over here, it's 200 is equal to, 200 is equal to 3. Positive 200 is equal to 3x. Oh, sorry, this isn't negative, this is positive. I was going to say there's a mistake there, yeah. Okay, so, which is essentially we are now exactly at the exact same function, right? So we go to divide this, 200 divided by 3. I'm going to go on the assumption that it's 66.7, and we'll check. But when we looked at our graph, that was the value they told us, so let's double check to make sure there are no errors there. But 200 divided by 3. And 66, yeah, and they rounded to a roughly 0.7. Perfect. So there we found our break-even points. Okay. To extend from that, a lot of times in business, companies pretty much want to set aside how much profit they're going to make. So let's say they decide to tell us that we want to have a profit of, for every shirt we sell, we want to make $6. Okay, $6 on every shirt. I'll say on every shirt, and then we'll build the function from there. Sorry. On every shirt. So in other words, our profit function needs to be equal to our 6x. Okay? And the company knows that it's going to cost us, our cost function we've already developed is our 5x plus 200. Okay? So in other words, they would use this to build the revenue. In other words, to find a price. What are we going to price our products at, right? So we know that our profit is equal to revenue minus cost, right? Revenue minus our cost. So with that being said, we plug our values in here. So our profit, we want it to be $6 per shirt. So our profit is going to be 6x is equal to r at x. We don't know what our revenue function is going to be. Subtracted from our cost function, which is our 5x plus 200. Okay. Now we want to get r at x by itself, so this is now going to become, when I move this to the other side, it will become the idea of positive. So now it becomes a sum of 2. So I'm just going to put the r at x on the left here, and you tell me if this is too confusing, this step. But then the 6x plus 5x plus 200. Does this make sense? This is the same idea if I moved it there. I just decided to keep the variable on the left. Okay, great. So now what we're going to do is we're going to continue our function. It becomes 6x plus 5x plus 200, which is 11x plus 200. So in other words, and I guess I should have incorporated in the profit function the negative 200 that we know we're going to have to incur. What this is saying is we need to price our products at $11 per shirt, and we have to get a fixed cost of 200 to eliminate our original negative 200 cost. So in other words, how this could possibly apply to business is that maybe you used to have a retail store and you're the manufacturer and you're selling to retail stores. So you decide to sell your shirts to the retailer, and the retailer can sell it whatever they like at $11 each, but you also charge them a premium. Maybe your brand is really good, and you say, in order to sell our brand, you need to pay us $200 as like a membership fee or an upfront premium fee, and then the shirts are $11 each from you. Okay, so that would be the revenue function to a company, and that would essentially eliminate that minus 200. Does that make sense? Mm-hmm. Yeah. Okay.